In Lesson 2.7, you'll be solving equations with rational numbers. Remember, rational numbers are those numbers that can be written as fractions. In our first example, instead of subtracting 7 and 36 hundredths from p, we're going to add 7 and 36 hundredths. Remember, whatever you do to one side, you have to do the exact same thing to the other side to keep it equal. When we're working with decimals, you'll also want to line up the decimal when you're adding or subtracting. Over on the left side, this will end up being 0, and p take away 0 is just p. And then on this side, 4 plus 6 is 10, 8, 9, 10, 11, 12. Decimal point straight down, 7 plus 2 plus 1 is 10. 10 and 20 hundredths really is just 10 and 2 tenths. Don't forget, you can always check your work by plugging your answer back into the problem. If we put 10 and 2 tenths here in place of p, 10 and 2 tenths minus 7 and 36 hundredths should equal 2 and 84 hundredths. In our next example, we have a fraction. Instead of adding 3/4 to each side, we're going to subtract 3/4 from each side. And when we're subtracting fractions, remember you need a common denominator, so I'm going to rewrite this top fraction as fourths. 2 times 2 is 4, so 1 times 2 is 2/4. And the bottom one's going to stay the same. So 2/4 minus 3/4. Once again, we are subtracting a fraction that's larger than what we started with, so change it to adding the opposite. Since they're different signs, you're not going to add the two, you're going to actually subtract. 3/4 minus 2/4 is 1/4. And this one right here has the greatest absolute value and it's negative, so it's negative 1/4. On this side, this will become 0 and you're left with just t. So t equals a negative 1/4. You can check your answer by plugging that back in. Negative 1/4 plus 3/4, that equals 2/4, which is the same as 1/2. You may want to pause the video and try the next two on your own. Draw your train tracks. Instead of subtracting 7 and 81 hundredths from t, we're going to add 7 and 81 hundredths. Again, don't forget to line up your decimal point. On the left side, we're going to be left with just t. And on the right side, 2 plus 1 is 3, 8 plus 3 is 11, 7 plus 4 plus 1 is 12. The decimal point was supposed to be straight down as well. So 12 and 13 hundredths. You can check your answer by plugging that back in. 12 and 13 hundredths minus 7 and 81 hundredths should equal 4 and 32 hundredths. Instead of adding 2/5 to both sides, we're going to subtract 2/5. When we're subtracting fractions, though, we need a common denominator, so I'm going to go ahead and rewrite this with a 10 in the denominator. In order to get to 10, we multiplied by 5, so 1 times 5 is 5, and this fraction was negative. And then in order to go from 5 to 10, we multiplied by 2. 2 times 2 is 4, and that's minus 4/10. Now, since we're subtracting with negatives, we're going to change it to adding the opposite, or chop minus. Now, since they're both the same sign, we're going to add 5/10 plus 4/10. 5 plus 4 is 9. Keep the denominator the same. And you also keep the sign when you're adding, and they're both the same sign. Over here, you'll have just y, and you can check your answer by plugging that back in. -9/10 plus 2/10 should equal -1/2. Next, we have some multiplication and division equations. In our first example, 4/7 b equals 16. You might think that you want to go and divide both sides by 4/7 instead of to undo this multiplying. However, when you divide fractions, you really multiply by the reciprocal. So I'm going to save ourselves a step and just go ahead and multiply by the reciprocal. When you take a number and multiply it by its reciprocal, you always get 1. The reason for that is these 7's will cancel and become 1. The 4's will cancel and become 1. So you will end up with just b on this side. I got a little ahead of myself. I forgot my train tracks. And if I multiply this side by 7/4, I have to multiply the other side by 7/4. I'll want to write this 16 as a fraction by putting it over 1. And then I'll want to simplify before multiplying to make my life a little easier. 16 and 4 can both be divided by 4. 4 goes into 4 once. 4 goes into 16 4 times. 4 times 7 is 28. And 1 times 1 is 1, which means 28 is our answer. You can check this by plugging it back in. 4/7 times 28 should equal 16. In our next example, instead of multiplying by -7.3, we're going to undo that by dividing by 7 3/10. A -7 3/10, I should say. And over on this side, a -7 3/10 divided by a -7 3/10, that's going to equal 1. And 1 times m is just m. On the other side, we're going to have to come over and do everybody's favorite long division. 78 4/10 divided by 7 3/10. When you're dividing decimals, this number cannot be a decimal number, so we have to move it over one place to make it a whole number, which means we have to also move this over one place to make it so it's still equivalent to what I started with. Basically, we just multiplied both numbers by 10. So it's really 584 divided by 73. 73 does not go into 5, it does not go into 58, so we have to see how many times it goes into 584. To help me figure that out, I might want to think about this as being 70. And 70 times 8 is going to be 560 because 7 times 8 is 56. 70 times 8 is 560. So that gives me a good starting point. If I want to check it to make sure or see where I'm at, 73 times 8. 8 times 3 is 24. 8 times 7 is 56, plus 2 more is 58. That actually works out perfectly. 73 goes into 584 8 times with nothing left over. So we're going to have an 8 over here, but it's going to be negative because when you have one of each, when you're multiplying or dividing, it's always going to be negative. Remember, good things happening to bad people is bad. You may want to stop the video and try the next problem on your own. Right, this is another one of those where we have a fraction attached to the variable, 4/5 times r. In order to get this to be just 1r, we can multiply by the reciprocal. And if I multiply this side by the reciprocal, I have to multiply the other side by the reciprocal as well. These 5's will cancel and become 1's. The 4's will cancel and become 1's, and we end up with just 1 times 1, which is 1, and then 1 times r, which is just r. On the other side, we'll want to write the negative 12 as a fraction by putting it over 1. Then we'll want to simplify before we multiply. 4 goes into 4 once. 4 goes into 12 3 times. 5 times 3 is 15. And a positive times a negative is going to be negative. Remember, good things happening to bad people is bad. You can check this by doing 4/5 times negative 15. That should equal negative 12. We have one last example where you need to write an equation and solve. It says during practice, a soccer player completed 18 goals, which were 9/25 of his goal attempts. Write and solve an equation to determine his goal attempts at the practice. My strategy with word problems is to ask myself what I don't know, and what I don't know, I make my variable. I don't know how many goal attempts, so I'm going to say A is going to equal the goal attempts. Then I'm going to go back and reread the problem and translate the words into an equation. A soccer player completed 18 goals, which were, that's going to be my equal sign, 9/25 of his goal attempts. Of in math means multiply. So 9/25 times his goal attempts. And we don't know his goal attempts, so we're going to call that A. Now we have another problem like this where we have a fraction attached to a variable or a fraction multiplied by a variable. If you multiply by the reciprocal, you can eliminate that fraction. So I'm going to multiply both sides by 25/9. Over on the right side, the 25s will become 1s, the 9s will become 1s, and you'll end up with just 1 times A, which is A. And on the other side, I'm going to write the 18 as a fraction by putting it over 1. And then I'm going to simplify right here before I start my multiplying. 9 goes into both of these. 9 goes into 9 once. 9 goes into 18 twice. 25 times 2 is 50. And 1 times 1 is 1. So there were 50 goal attempts.